Hello everyone, welcome to this research project under the title Landfill Detection Using Aerial Imagery and Computer Vision. This research project is done by me, Yassine Ibork, and Dr. Asmaa Mourhir. Illegal landfills cause a significant problem to the environmental protection agencies as they are very difficult to detect and monitor. In fact, these illegal dump sites cause health risks to the nearby population since they serve as a medium through which disease-causing organisms might grow. Furthermore, these illegal dump sites have an impact on the pollution of our environment, including air, water, and soil. Therefore, the government is taking a lot of initiatives in order to overcome this limitation, such as hiring people that have to dig for these illegal dump sites manually, or raising people awareness concerning this issue. However, the approach taken by the government is very limited in terms of costs and results. Therefore, we suggest to automate the process of the detection of illegal landfills by leveraging computer vision and aerial imagery. The presentation plan is as follows. I will start by talking about deep learning models that we have selected for the sake of this research project. Then I will talk about the data collection process, which involves data collection and pre-processing. After that, I will talk about the training process and I will move to the results, and finally I will talk about the conclusion and the future work. For the sake of this research project, we opted for three different deep learning models. Each one of them targets a specific computer vision task. The first one is Mask RCNN, which is used for image segmentation. The second one is YOLO VH, which is used for object detection, and the third one is ResNet 50, which is used for image classification. Now let's talk about the data collection for this research project. In fact, the data that we are using for this research project is coming from the aerial waste data set. These data sets have around 10,000 images that are coming from three different sources. Some images are coming from the ATA, others are coming from WorldView 3, and the last ones are coming from Google Earth. In fact, this data set is designed to identify the existence of illegal landfills, and it is being annotated using the different formats. Some of the images are binary classified, others we have multi-class annotation for them. In fact, we have 22 classes within this data set, which are different types of waste, and a small sample of the data set, which is about 169 images, are being segmented. Now we are going to talk about the data preparation for YOLO V8. YOLO V8 is the model responsible for object detection. The first thing that we did is that we picked only segmented images from this data set. After that, we converted the segmentation mask into bounding boxes. Then we organized the data set so that it will fit with the ultra-realistic YOLO format. After that, we applied the augmentation to the data set using image cropping and image flipping. And then we created two sets of our data set, the validation set and the training set. The training set is about 80% of our data set, and the validation set, which is about 20% of our data set. Now let's talk about the data preparation for Mask RCNN. Mask RCNN is the model responsible for image segmentation. The first thing that we did is that we cleaned the data sets from images that are not segmented. Then we applied the bounding box labels to the data set. We followed the same approach we did with the YOLO V8. After that, we annotated the data set using the COCO-like format. Then we applied augmentation to the data set, including image flipping and image cropping. And finally, we created the two sets of the data set, the training set, which is 80% of our data set, and the validation set, which is about 20% of our data set. Now we are going to talk about the data preparation for ResNet 50. The first thing that we did is that we picked a small sample from our data set, which was about 3,500 images. Then we applied augmentation to the data set. After that, we created two sets, the training set, which is 80% of our data set, and the validation set, which is about 20% of our data set. The model configuration for this project was based on YOLO V8 architecture, utilizing YOLO V8x.pg pre-trained weights as the fundamental model. In fact, input images were resized to a consistent dimension of 640 by 640 pixels, aligning with the model's requirements. During the training phase, the model underwent 11 epochs, and a batch size of 16 images were employed. In fact, as I said, we adopted transfer learning. The pre-trained layers of the model, typically the backbone, are used to leverage the learned patterns from the original dataset. Then we have the fine-tuning layers, which are the detection head layers, were retrained. The detection head layers are more task-specific and learn patterns unique to the new dataset. Now let's talk about the retraining of the mask RCNN model. For this task purpose, we have leveraged Detector 2, which is a framework developed by Google. Basically, this framework contains all the dependencies that mask RCNN will need in order to be retrained. Several configurations were made in order to ensure that the fine-tuning of the model will be successful. The first thing is the model weights, which were initialized from a pre-trained COCO instance segmentation model, which is available in the model zoo. Leveraging pre-trained weights allows the model to start with knowledge gained from a broader data set, which can be fine-tuned for task-specific. Then we have the batch size. The batch size was set to 10 images per batch. For the learning rate, we have used learning rates of 0.0025, and the model went through 10,000 iterations for retraining. Now let's move on to talk about the retraining of ResNet 50. The retraining of ResNet 50 involved specific configurations and hyperparameters to fine-tune the pre-trained model for the detection of illegal landfills. Here is the breakdown of the training configuration. Concerning the hyperparameters, we have used the learning rate, which was set to 0.001, a batch size of 16 images, and the number of epochs that the model underwent is 11 epochs. For fine-tuning, all the layers of the pre-trained ResNet 50 model were frozen, except the finally fully connected layer, which was fine-tuned during the retraining of our dataset. Now let's give a small summary concerning the results. So YOLO V8 showed an accuracy of 60%, recall of 60%, precision of 50%. Mask RCNN showed an accuracy of 90%, precision of 94%, recall of 95%. And ResNet 50 showed an accuracy of 94%, precision of 96%, a recall of 97%. As we can see that the image classification task showed the highest accuracy among the others. And this is because the image classification is much less complex than segmentation or object detection. Moreover, this task for image classification, we had a very huge data set compared to the one that we have used for object detection of and image segmentation. The image size was about 3,500 images for image classification and only 500 images for object segmentation and detection. So mask RCNN showed also a very high accuracy of 90%, which is not that far from the one of ResNet 50. And then we have YOLO V8, which showed the accuracy metrics that are very low compared to mask RCNN. It showed an accuracy of 60%, precision of 50%, and a recall of 60%. And this low accuracy metrics at the level of YOLO V8 maybe are influenced by the number of epochs it has been trained on. since mask RCNN was trained longer than YOLO V8. So in order to improve the accuracy of this model, we might need to improve the number of epochs the model went through. As a conclusion, in this research project, we have worked on the automation of the detection of illegal landfills. We have the approach that we followed is that we use the deep learning models. The models that we have used are ResNet 50, Mask RCNN, and YOLO V8. ResNet 50 and Mask RCNN showed very high accuracy, while YOLO V8 showed a very low one. Concerning our future work, we would like to build a GIS-enabled platform which will allow for real-time detection of illegal landfills. And for that, we would like to leverage the best practices of machine learning operations in order to overcome the hidden technical depths of machine learning systems. We would like also to engage with the policymakers in order to seek some fundings for this project so that we can have it functional in our day-to-day operations. Thank you so much for your attention.